This is the galaxy, and this picture contains more wonders and places than you or I could ever comprehend. And here are a million billion huge stars, black holes, gas giants, wandering comets, and yes, our little home, the Earth. And with all that, it is strange to think that the same principles that guide these large cosmic bodies are the same laws that apply to every single movement and action that every single person does every single day. And just what are these laws? Well, the person who can best explain that lived back in 17th century England. His name, Sir Isaac Newton. This is the cosmos, Newton's universe. Perhaps the most famous story of Newton came about when he was sitting in his garden under his apple tree. It is said that an apple came loose from its branch and fell to the earth, hitting Newton's head on the way. It was at that moment that Newton was inspired to discover the laws by which gravity attracts objects. While the details of this story may have changed over the centuries, one thing remains clear. The laws of motion Newton authored are still considered the hallmark of mechanical physics even today. According to Newton's first law, an object at rest will remain at rest, and an object in motion will remain at the same velocity unless acted upon by an external force. Let's look at an example. If I take this toy train and set it on the table, it doesn't roll forward because there is no force to act on it. However, when I push it with my hand, it moves forward. In this case, my hand acts as the outside force. Now, if you notice, when the train is moving forward, it doesn't continue at the same speed, and it eventually comes to a stop. Now, you might think that this defies Newton's first law, because there is no outside force acting on it. But there actually is. Friction between the wheels of the train and the table act as the outside force slowing it down. You'll find it's quite difficult to break the laws of nature. Newton's second law is perhaps the most important in terms of the mathematics behind the physical world. It states that the force applied to an object is equal to the change in that object's momentum, or mass times velocity, over time. With this equation, we can get many others that are the basic building blocks for mathematical physics. Newton's final law is perhaps the most quoted. For every action, there is an equal and opposite reaction. This law is also known as the action-reaction law and can be explained in the simplest of terms by standing up. While I stand, I exert a force on the floor due to the Earth's gravity pulling me towards its center. At the same time, the floor pushes back on me with the same magnitude of force, causing me to remain stationary, either falling through the ground or flying into the cosmos. Now we understand how Newton's laws applies to things the size of us humans. But how do they apply to large celestial bodies? Well, the answer lies in the same force that tethers us to the Earth: gravity. When the Earth circles the Sun, the force of gravity between the Sun and the Earth causes an attractive force between them. At the same time, the Earth is moving in a straight, perpendicular line. These combine to create a curved pathway for the Earth around the Sun, which, when continued, takes exactly 1 Earth year to complete a full rotation.
Earth. This is our home. This tiny blue speck in the middle of a black sea, surrounded by lights and spinning at fantastic speeds in a universe that, in reality, we know very little about. But, thanks to Sir Isaac Newton, our cosmos have been made a little clearer, so that the exploration of the unknown can continue.